and tell you about a place where metal deposits are being made in real time. And you're probably aware that at the spreading ridges, the global plate tectonic system, so this would be a mid-ocean ridge. So we decompress the mantle, we melt it, partially melt, so this is not red, but you get the idea that this is going to make, this melt makes the basaltic crust, and then, because this is mostly underwater, what happens on the flanks of the new crust is that ocean water starts to be circulated through the crust. It cools it. It also leaches out elements from the ocean crust and deposits them in what are known as smoker systems. And a particularly important one from the point of view of metals are the black smokers. These are chimneys which are venting hot fluid back into the ocean, temperatures of the order of, well, up to 400 degrees Celsius, so less than or equal to that. When the hot water, which has been heated by proximity to the magma chambers below the ridge, and then circulates back up to the ocean floor, ambient temperature of the ocean floor, let's say 4 degrees Celsius. It can be even colder than that. But the shock of going from 400 degrees Celsius water into 4 degrees is such that when you drop the temperature on the fluid coming out of these vents, metal compounds precipitate. And what is precipitated are copper, zinc, silver, sulfides. These fluids are rich in sulfur, partly coming from the gases coming out of the Earth's mantle and via the melts that are being transitioned to the crust, and also from leaching out of the crust. So all of these guys, and lead, are forming in chimneys on the ocean floor. These are made over periods of just 10s, 20s of years. They have a colossally high grade. So some of the levels of copper in these chimneys around the black smokers. So the chimney is the structure out of which the fluid is coming. In the chimneys, high grade, copper, zinc, silver, lead, sulfides. And by high grade, I mean up to 30 weight%. So they glisten. You can see the sulfides in these things. There are companies that are actively exploring the ocean ridges and those that, for example, in other places like Back-Arc basins in Papua New Guinea, the Manus Basin. And there is a large enough number of these chimneys that it's conceivable to think of mining them, to running a bulldozer over the floor and crunching the stuff up, putting it into a barge and taking it almost directly to a smelter. So if any of you had thought to ask the question, well, what's the tonnage? You've got high grades, but is there enough of it? Probably globally, there's a lot, but certainly one of the problems with this is there's not enough of it to replace the deposits on land. So although this is a potentially renewable resource, it is insufficient in terms of its total volume and mass to substitute in for what we currently exploit out of some of the major land-based mines. But I wanted to show you this in the sense of renewable versus non-renewable. This is a renewable metal deposit, but it's not sufficient to sustain our voracious need for metals, for which we will continue to rely on mines on land.